Hey folks, this is the final video in section 3.2, and I'd like for you to go all the way in your notes down to page 5, where it talks about the height of a projected object. Height of a projected object. So this would be something like a ball that's being thrown into the air, a bullet being shot into the air, a rocket being shot into the air. All of these are projected objects, and we want to look at their heights. So the generic equation you can see there on the screen in green is S of t is equal to negative 16t squared plus v sub 0 or v sub naught times t plus s sub 0 or s sub naught. So let's define a few of these things first. S of t is going to be the height measured in feet. S sub naught is going to be my initial height. Where did the ball start? Where does the rocket start? V sub naught is going to be my initial velocity. The rocket started out at a velocity of, and that would be my initial velocity. T is going to be my time, and time is always going to be measured in seconds. So we have an example here that says a ball is thrown upward from an initial height of 100 feet, an initial velocity of 80 feet per second. And you're asked to write the function that describes the above situation. I would like for you to pause the video right now and write what you think is the function in the blank for part A, using what you know according to what I just gave you. Now, you've come back and hopefully you've written an equation. The equation that you should have written was S of t is equal to negative 16t squared plus 80t plus 100. Is that what you got? Part B says, if this graph looks like the figure below, and it shows the coordinate at the bottom of the figure of being 4.8, 115.36, what does this coordinate mean for this particular situation? Again, pause the video and write what you think this coordinate means, or at least think of what this coordinate means to you. All right, now that you're back, in 4.8 seconds, remember that t, my first piece there, the old x's, t is for time. And so in 4.8 seconds, the height of the ball is going to be 115.36 feet. Is that what you got? Look at part C. After how many seconds? Now, before I keep on reading, this is talking about time. This is asking me for an answer of time. So let's keep reading. After how many seconds does the projectile reach its maximum height? Now, the directions say I'm supposed to determine this analytically, which means I'm not graphing on the calculator. I'm doing some math and I'm showing my work on paper to find this. So look at what you have here. The maximum height, we know that this is another word for vertex. And now that we've done some studying on how to find the vertex by using a shortcut, we can use that shortcut that we talked about in a previous video. So the first thing I'm going to do is I'm going to use my shortcut, negative b over 2a. And my b value I know is 80. My a value is negative 16. So I'm going to have negative 80 over 2 times negative 16. Simplify your fraction here and you have 2.5. So what exactly does this mean? My projectile is going to reach the maximum height in 2.5 seconds or 2.5 seconds. Part D says, what is the maximum height? So part C, you found how long it took to get to the maximum height. Now for part D, you want to find out what that maximum height is. So we want to find out what is S of 2.5. So let's take 2.5 and plug it in for all of the t's in our equation. Simplify the equation and you get 200. What does this mean? My height, the maximum height of my object, will be 200 feet. It will reach 200 feet in the air as a maximum. Then part E says, when will the ball hit the ground? When? Again, I'm looking for an answer of time. And my directions say that I should determine this graphically. So I want you to pause the video And I want you to go to your graphing calculator and I want you to type in this equation. Now, instead of S's and T's, you're still going to be using X's and Y's. So you want to go to your Y equals and you want to enter this in to your Y equals screen. Now, you have had a how-to in this very set of notes that talked about finding the zeros or the x-intercepts. And this is what we're looking for. I want to find when the ball hits the ground. So you're looking at your calculator screen, and hopefully in your calculator screen, you have been able to find the zero, the right-hand zero. There were two zeros. There were two places where the parabola crossed over the x-axis. You want to find the one on the right-hand side. What did you find for that?